The graph of y equals b, b being just like a number, is a what type of line? What kind of line is that?
Horizontal.
Y equals b is horizontal because it goes through the y-axis. Remember we had that acronym, it's right over there on the whiteboard, it says HOI of x. So if it's y equals a number, it's a horizontal line. Meaning it looks like this, like the horizon. The line of graph y equals b passes through the point, it passes through the y-intercept. So for the y-intercept, does a 0 go in the x spot or the y spot? So we think about a coordinate pair. Where would the 0 go if it's a y-intercept? This one. Because it's got to be, it's not moving left or right, and so the first number is 0, and then the second number would be whatever number you're going through. So it crosses at the y-intercept, which would be 0, and then your number, b. So if it's x equals a, is that horizontal or vertical? Vertical. So it looks like this. So it's undefined. The line passes through the point, it'll pass through an x-intercept. So an x-intercept would be the number and then 0. Please remember that domain is all the possible x values, and that goes from left to right. Range is all the possible y values, that goes from the lowest to the highest. Okay, we're going to graph. So in this first graphing example, our domain is restricted. It says that graph the function y equals 2x plus 2 with a domain of x is greater than or equal to 0. Then identify the range. So what that means is only graph the numbers that are greater than or equal to 0. Don't do anything that's less than 0. So without plugging in, when x is 0, what is y equal to? Okay, why is it 2? Kayla, why is it 2? It's the y-intercept. You look at your equation, our y-intercept is 2 because it's a number by itself. And we know the y-intercept is on the y-axis, and that's where x equals 0. So we put a 2 here. What's our slope? 2. So our slope is 2, so that means that's change in y is 2, and then the change in x, you could put it over 1 to make it to a fraction. Change in x is 1. So every time x goes up by 1, y goes up by 2. So you should just fill in with a pattern, right? 2, and then 4, 6, 8, 10. The slope tells you it goes plus 2 when the x goes up 1. So you can do that without having to plug in numbers. Or you guys know how to graph. So we're graphing everything greater than or equal to 0. So we're going to start at 0. We know the y-intercept is 2. Y'all know how to graph things like this. We've done it like a million times now. And it's going to go up to right 1. Or you can just follow the points that you plugged in the table. It should give you the same outcome. Okay, we're using an inequality. Should I connect the dots? Yes. Yeah, it's everything, not just the whole numbers, everything greater than or equal to 0. What kind of line is that? So we connect them and we put an arrow. Why am I not going the other way? Tell your partner, why are we not going left? Okay, could someone raise your hand and give me a good explanation? Why are we not going to the left? I know we got some ideas. Joe?
Equal to 0?
Yeah. So everything, if we went left, what would that be, Joe? That'd be less than 0.
Yeah.
Do we want less than 0? No, we only want greater than or equal to 0. So we're only going to go to the right. So that's why we're connecting it with array. That's called array when it's only one-sided. Because what we say is the domain is restricted. If it's telling you only do the domain from this point on, that would be called a restricted domain, or from here to here. But we should have an arrow pointing right because it says everything greater than or equal to 0. So make sure you have an arrow pointing to the right because it keeps going in that direction, but we do not go to the left. What's the range?
Range?
Yeah, so look at so my range goes, what's the lowest? Up.
2 to 10.
The range starts at 2. So we'd say y values greater than or equal to 2. Where does it stop going up? Does it stop? No. So that's your range. This right here. Y values greater than or equal to 2 is your range because it's everything at that point or higher. So notice how the axes are not centered in the graph. That's totally fine. That's totally allowed. I just want you to notice that. When you're good, flip it over. I think we just have one more example. After visiting relatives who live 200 miles away, your family drives home at an average speed of 50 miles per hour. Your distance, d, in miles from home is modeled by the function rule. D, so for distance, is equal to 200 minus 50t, where t is time in hours spent driving. Graph the function and identify its domain and its range. Okay, when we're doing graphs like this, you got to make sure you scale it correctly. You need to label the title, the x-axis, the y-axis. If you don't do that, it's incomplete. I know there's questions like that on the end of course exam, and so you'll be docked points for that. So you got to label, you got to be accurate as you do this. Okay. Let's look at the letters here. So we got variables. We have t for time and d for distance. Which one is like the x? Which one is the cause or the independent variable? T for time. Okay, so the t is going to go on the x-axis. And the distance, so the longer you drive, the closer you are to home. So distance is like your y value here, your output. So label those on your graph. We also need to actually label with titles. So what are we doing in this problem? We're driving home. So we could literally title the graph driving home. Great, now you have a title. T is for time, so down here on the x-axis, or the t-axis, you need to label that it stands for time. Make sure you leave room because we got to label it with numbers. Time in what distance or what unit?
In hours.
Hours. So be specific. Is time in hours? And on the y-axis, you have distance. Distance in what unit?
Miles.
Miles. It'd be distance from home, I think, right? Because you're driving home? Yep. Okay, now we got a label. Let's look at our equation. Our equation says distance equals 200 minus 50t. What is the y-intercept, guys? Where's it going to start? Kirsten, where's it going to start? 200. So on the y-axis, on the where it says d, you're going to have to go at least up to 200. And then we're not really sure how many hours. We could think about it, right? So if he starts at 200 miles and he goes 50 miles per hour, how many hours is it going to take him? 4. Okay. Here's my tip to you. So if you're doing something that's in slope-intercept form, look at the slope, and it will help you figure out how to scale it. So our slope, I'll just kind of off to the side. Here's our equation. D equals 200 minus 50t. We know it needs to start at least as high as 200. We know that the hours need to go at least up to 4 because that's how many hours it's going to take. But here's another way you can do it. So how can I make my slope into a fraction?
Over 1.
Over 1. This tells you how you should have your x and y axis change. So if you look at your slope, it's 50 over 1, change in y over change in x. So if I were you, I would have my y-axis go by 50s. I would have my x-axis go by 1s. But not every single square. That's not what I mean by that. Make sure it can go up to 200 at least, probably up to 250. Make sure that the x-axis goes up to at least 4, probably 5. So we're going to spread it out, because what we don't want for these type of graphs is for it to just be bunched up in the bottom left-hand corner. But that tells us, okay, skip by those numbers, and that's going to make your graph really nice for you. That way when you do the slope, you go down 50 over 1. It's really easy to graph it. So let's have our x-axis go by 1s. You want to spread it out. It looks like is there 20 squares or 20? I think there's 20 squares. So that means that we probably want it to go up to 5. We can skip 4 squares each and label 1. So I'm going to go 1, 2, 3, 4 and label 1. You want to spread it out. 1, 2, 3, 4, 2. 1, 2, 3, 4, 3. 1, 2, 3, 4, 4, and the last one's 5. Since you're going to end at 4, you don't want 4 to be at the very edge. Let's do the same thing for the y-axis, but instead of going by 1s, we're going to go by our change in y, which would be 50. So we'll skip 4 and go up 50. 100. I'm skipping 4 squares. 150. 200, and that should end us right at 250. This will make it easy to graph. Okay, now you just got to plot the points. We know that it starts at 200 because that's the y-intercept. Your y-intercept on the y-axis. And our slope is negative 50, right? So will that go up or down? Down 50, and how far to the right? 1. 1 square? No, 1 hour, right? So go down 50 miles over 1 hour. See, look at that. Now it's going to hit perfectly each time. That's why you want to scale it like that. Down 50, right 1. Oh, whoops, messed that up. There. Down 50, right 1. Down 50, right 1. And connect that with a line, because you can have parts of hours, right? It's going to be continuous. You can have parts of hours and parts of miles. Since it's a continuous graph, then we're going to have inequalities for our domain and range. Can you please talk with your partner? What's your domain from left to right? What's your range from lowest to highest? Okay. What is, Lillian, what am I going to label for my domain? From left to right. Where does it start? We're looking on the x-axis. That's where it ends. Where does it start?
0.
Yeah. So it goes from 0, and we say less than or equal to x, less than or equal to 4. Carson Milbrant, can you give me the range?
Is 200, 0.
So we start by the lowest number, 0, less than or equal to y, less than or equal to 200. Okay, that is a completed graph. You see how you've labeled t and d. You labeled the x and y axis. You gave it a title. You scaled it. And then you told me the domain and range. Last question for you is on the side. Why do we only have positive, like we only have the positive quadrant? So the x and y axis are on the bottom left, sorry, on the bottom and on the side. Why don't we have the entire coordinate grid? So why have they been moved to the bottom and to the left? Why does that make sense?
Because they're each
What is it, Kirsten?
negatives.
Right, do we have negative time? Negative distance? No, so we only want the positive quadrant. So as you're working on word problems today, think about it. Can I have negative numbers of this thing? Probably not. So probably you're going to label your x and y axis, draw them in on the side and on the bottom like this. Okay, that's all, folks. Thank you.